Hello, math students. Welcome to the world of Mathematics 10. This is Michael L. Montalia, your math teacher. Here in San Miguel National High School, this is our Quarter 3, Module 3. Handa na ba kayo? Come on, let's do it! Illustrating the combination of objects. This is Quarter 3, Module 3 of our Mathematics 10. On this module, you have the following learning objectives. We have the first one, you will define combinations. Second, translate combinations into its notation form. The combination of n objects taken are at a time. Then we have the third, find the combination of objects. And the last one is, you will give examples of combinations in real-life situations. Before this, let us recall your lesson from module number 1 and 2. First question, this is a 22nd question. What is the value of 5 factorial, 3 factorial? Choices, A 720, B 360, C 120, D 15. Timer starts now. Okay, stop. Let's see the correct answer. Correct answer is letter A. Okay, we have an answer which is equal to 720. Another 22nd question. What is the value of permutation 5 taken 5 at a time? Choices, A 720, B 360, C 120, D 15. Timer starts now. Okay, stop. Correct answer is letter C, 120. Okay, we have this one. Third question is a 32nd question. What is the value of n in permutation of n taken 5 equals 6,720? Choices, A 6, B 7, C 8, D 9. Timer starts now. Okay, stop. Let's see your answer, or let's check your answers. Correct answer is letter C. That is n equals 8. I hope you got them all. That's in. Okay. Let's proceed now to this part. Consider the following schematic diagram. Okay, we have here places A, L, T, and O. And then we have routes there represented by the curved line. And then this one. So here we are going to answer the following questions. Okay. So first question, how many routes are there from A to T via L? So from this point, we have point A going to T via L. So let me guide you for this. So we can have this one, A, L, and then you can arrive at T. That is one count. Next, here, second, another one, third count. We can also use this way for our fourth count. And then this one for our fifth count. Okay, so we have 5 routes. But I can do more routes. I will use now the blue mark. So I will have this from A going to T. So I will use AL then here. Okay, I hope that you know already what will be the next. And then A here. Okay, that is the 6 and this is the 7. Then we have here another way for our 8 count or 8 route. Then we have the 9. And then we have another one here for our 10th route. So therefore, we have a total of 10 routes here from A going to T via L. So instead of doing that, we can use this one. From A to L, we have 5 routes. And then from L going to T, we have 2 routes. According to our FCP, just multiply this, 5 and 2, we'll get an answer which is equal to, okay, 10. I hope you got the first one. Now, let's proceed to the second problem. How many routes are there from point A going to T and return to A without using the same road twice? Okay, so how are we going to analyze the problem? We are not going to pass the same road twice. For example, we have A going to L here, then L, T here. You cannot use TL the same or this route again if you will return to A. I hope you got it. So how are we going to do it? So here we have solved already problem letter a while ago. So we can use the counting of the routes. Now we can write here from A going to L we have 5 routes. Then from L going to T we have 2 routes. But since we cannot use the same road twice or the same route again in returning, this LT, instead of 2 routes, we only have 1 route to be used if we'll return. So L going to T, we have 2 routes, but T going to L, we have 1 route. Why? Because we cannot use the other route which we had used before. And then from L going to A, we have now only 4 routes because we have used 1 earlier from A going to L. Okay, I hope you got it. So we have the numbers 5, 2, 1, 4, and then just multiply them. We'll get an answer which is equal to, okay, 40. I hope you got the second problem. How many routes are there from L going to O via T? Okay, so if you will take of this, it's so easy, right? So you can have LTO this way and another one LTO this one. So let me have that. Okay, we have this L going to T going to O, so 1. And then another one L going to T, then O. So you only have two, or in short, from L to T, you have how many routes? Two. And then from T to O, you have one. So therefore, 2 times 1, your answer is equal to 2. And that is our answer for the third problem. I hope you got them all. So let's proceed now to the next one. How many possible permutations are there in the letters from the name Arlene? Okay, so we have now the answer. Okay, we are going to have this Arlene, that is 6 letters. So you are going to write here 6 factorial. Ayan. Then, because we have two identical letters, or this is an example of distinguishable permutation, you are going to divide that by 2 factorial, because you have two same letters here. And then if you are going to evaluate or simplify this, you will have an answer which is equal to, very good, that is equal to 360. Ayan. Let's proceed now to the third question. Do you still remember our lesson for this? Okay, we have a basic permutation. And how many ways can Audrey arrange 5 different seedlings in a row? Okay, so we have 5. So therefore, just have it 5 factorial. Okay, so you have that 5 factorial for you to find the answer. And 5 factorial is 5 times 4 times 3 times 2 times 1. And your answer is equal to, yan, 120. Very good. So let's proceed now to the next one. Find the number of different arrangements of the set of the 5 letters COVID. Wow, COVID. Okay. Taken 2 at a time. Okay. So we have here a permutation of, ayan, permutation of 5 taken how many at a time? So we have 2. So 5 taken 2. And we have an answer for that, which is equal to, very good, your answer is equal to 20. Ayan. So let's proceed now to number 5. Do you still remember our circular permutations last time? Yes, of course. What is the formula of our circular permutation? You are going to you are going to subtract that n by, very good, by 1. And then have a factorial for that quantity n minus 1. That will be the formula for your circular permutations. So therefore, we have this. Instead of 7 factorial, we have an answer which is equal to 6 factorial, and simplify that further. That will give you an answer which is equal to 720. That's correct. Okay? I hope you got them all. Ayan. Let's proceed now to this. What's new? So here we have pictures or images of the fruits. Then from the given fruits above, you will imagine that you will get 2 fruits. Ayan. So 2 fruits here. For example, we have banana. Okay, we'll get this one. Banana, and we have the apple. For example, you're going to pick 2 fruits or get 2 fruits from this list. Okay, so we have 2. And then after that, since you have selected banana and apple, okay, this time you are going to select 1 piece at a time. Okay, so if you are going to select 1 piece at a time, you can have this one, banana and apple, or banana or apple. So you have how many how many ways? Of course, you have 2 ways because 1 is for banana and 1 is for apple. Okay? Simple, right? So if you are going to count the number of ways, you have 2 possible selections here. Okay? Now let's proceed to the second. How about using the same situation, two fruits, banana and apple again, but this time you will select two fruits at a time. Okay. So how are you going to do it? For example, you can have this banana, apple, or apple, banana. Either way, that is considered as one way only. Okay? So why one way? Because banana and apple or apple and banana are just the same. You are selecting. You are not arranging like our lesson last time on permutation. Again, you are now selecting. So therefore, if you interchange them, the count is just the same. So there is only one way. And we have the number of ways, we have one possible selection. I hope you got that. How about if you have three fruits? Okay. For example, you have the orange, the banana, and apple. How are you going to do it? Okay. You have three ways. What are those three ways? Okay. You can have apple, banana, and orange. So, because that is one at a time. Take note, one at a time. So, therefore, you have three ways. Okay, basic, right? And then you have three possible selections for that. Okay. Now, let's proceed to the same situation. Three fruits, but this time two at a time. Okay. So, how are you going to do it? Since you are selecting two at a time, you can have this one, three ways. What are those three ways? Banana, orange, orange, apple, banana, apple. So you have three ways for that. Remember, if you interchange them, that is only counted as one. Why? Because you are not arranging here. You are selecting. Okay? So, how about same three fruits again, but this time three at a time. Okay. After you select, or if you will select from that, all of them will be taken on your selection. So, how is it? Of course, you have one way. And that is one possible selection. Okay? So, easy. Let's proceed to this. How about four at a time or four fruits? If you have four fruits to be selected, okay, but this time one at a time, so of course you are going to do it separately. We have the orange, we have the apple, banana, and pineapple. So therefore we have four ways. I hope you got it. Okay. So now same problem. Okay. Four fruits. Select two pieces of fruits, two at a time. Okay. So how are you going to do it? Two at a time. So you can have this um, orange apple, apple banana, banana pineapple, pineapple orange, orange banana, pineapple apple. So a total of how many ways? You have six ways, and that is six possible selections. I hope you got the second one. Same problem. This time, three at a time. Okay? How are you going to do it? So we can have orange, pineapple, banana, one count. Next, apple, banana, pineapple. So you have two. Next, banana, pineapple, orange. We have three. Then, pineapple, orange, apple. So we have four. Aside from them, no more selections using three at a time. So therefore, we have an answer which is equal to four ways. Correct. And then we have the number of selections, four possible selections. Okay, I hope you got it. Let's proceed to the same problem, but this time four at a time. So if you're going to take them four at a time, of course, you will get them all at a time. And that is one way. So we have now one possible selection. I hope you got them all. Now let's proceed for this table. Okay, the results. So we have this number of objects, the number of objects taken at a time, and then for our number of possible selections, which will be our combinations later. So we have this numbers. I hope you got them all. Then we are going to have these questions now. Does the order of selecting the objects matter? What do you call its unique selection? Can you find any pattern in the results? Can you think of other ways of finding these answers? Ayan. So, those are the questions that will be answered after you are done with this module number 3. Ayan. So, what is it? We have this. Our topic is all about combinations. Ayan. Ano nga ba ang combination? It is a selection, ayan, of items from a collection such that the order, take note of this, the order does not matter or the order is not important. Okay. How is it? When you say order is not important, if you interchange them, no matter how you interchange them, you will consider that as only one count. Okay? So let's proceed now. And combinations, example 1. Okay. Suppose you were assigned by your teacher to be the leader of your group for your project. You were given the freedom to choose 4 of your classmates to be your group mates. If you choose Charlotte, Micah, Chloe, and Philip, does it make difference if you choose Philip, Micah, Charlotte, and Chloe? Of course not, because the list refers to the same people. Take note. If they are just the same. So therefore, your combination or your selection is only one count. On the other hand, if you choose Charlotte, Micah, Chloe, and Maan, okay, there is additional here. Now this is another combination and a different from the first combination cited. Okay, so I hope you got it. Let's proceed now to the next one. Example number 2. Okay. Given the 3 donuts, say chocolate, strawberry, and milky. There are 3 combinations of 2 that can be chosen from the set. Okay, when you are going to use 2 at a time, so we have chocolate and strawberry, milky and chocolate, strawberry and milky. So we have 3 combinations if you are going to have 2 at a time. Okay. If you have 3 at a time, for example, this one, for example, number 3, we have points A, B, C, D, of which no 3 are collinear. Ibig sabihin nun, wala sila sa isang line, or they do not lie on the same line. So, let's have this drawing or figure. We have A, B, C, D. How many triangles can be formed from this? Okay, so we can have this triangle A, B, C, triangle B, C, D. Then we have triangle A, B, D, and C, D, A. Aside from them, you will not get other triangles. So we only have 4 different triangles here. How about if you will say, sir, how about ACB? Take note, ACB and ABC, or those triangles, are just the same. If you will name it as BAC, that is also the same with triangle ABC. So we have these 4 triangles only for this example number 3. Okay? Yeah. So what are going to remember for this? We have the number of combinations of n objects taken R at a time that will be denoted by these symbols. So you have these symbols, but they have the same meaning, of course. And we are going to use this for our combination problems. Usually, the first one, this first part, okay, is usually used in our grade 10 mathematics. Okay, here we have the formula for combinations, and we have here combination of n taken r at a time is equal to n factorial over n minus r quantity factorial multiplied by r factorial. So, this is not new to you from the formula on permutation, but if you will observe this part, I am encircling here. This is the formula for our permutation, right? So I may write that this way: permutation of n taken r at a time. Okay, the encircled one is the formula for our permutation n taken r at a time. Then just divide that permutation by your r factorial, and that will be the same with our combination of n objects taken r at a time. Okay, so we have that from the formula, the number of combinations for that. Then we have the n, which is the total number of elements in the set, the original one, and then the r, which is the number of elements you choose from this set, or what we call the one used at a time. Okay, how many at a time? So that will be your r. Always remember that formula. So for example, we have the first one in a 10-item mathematics problem solving test. How many ways can you select? 5 problems to solve. Okay. So here we are going to use combination. Why combination? Because let's say for example from that 1 to 10, we'll select 5, 4, 3, 2, 1. Okay, something like that. And if you will select 1, 2, 3, 4, 5, or 3, 2, 1, 4, 5, you are just, or you will just answer the same problem, right? So that will be counted as one count only, okay? So, or one way only. So, and that means you are going to have a combination here. And by the way, because of this word select, okay, that means we are going to use combination. So therefore, we can apply now our formula for combination. So we can have combination of 10 taken 5, and then by substituting to the formula, we can have this. Simplifying further, you can have this, and then you have an answer which is equal to 250 ways. Okay, so in other way, you can have the permutation. The permutation of that is equal to uh, we have this permutation of 10 taken 5. Okay, divide your answer by r, which is 5 factorial. You will get an answer which is equal to 252 ways. Okay, so I hope that's clear. Let's proceed now to example number 2. For example number 2, we have this problem: in how many ways can a committee consisting of 4 members be formed from 8 people? Okay. If you will encounter this word committee, ayan. So no matter how you select or how you arrange or whatever, what you do with the 4 members of this committee, for example, member 1, member 2, member 3, member 4, or member 2, member 3, member 1, member 4, something like that. Okay, that is only one way, considered as one. And therefore, because of that, you are going to use combination here. committee, another one is team. Okay, those are some of the words which are related to combination. So therefore, we are going to apply combination, and our solution will be this one. Combination of 8 taken 4, and of course, we have that uh, substitution for our final answer, which is equal to 70 ways. You may also use the permutation of 8 taken 4 divided by the 4 factorial, and you will get the same answer, which is equal to 70 ways. I hope you got it. Yeah. So let's have this one. Using the given combinations, complete the table, and then just find the n and r. So it's so easy, right? Okay. But this time, okay, we'll just take off the notation. So number of objects is n. Okay. Then we have r is 1. We have 5, 2, 10, 4. Easy, right? For this independent activity number 2, write the given combination in factorials. Choose the correct answer from the box below. Okay, so we have the choices. And then we have these problems 1 to 5. Then you are going to choose your answer or your solution from this combination problem or combination notation. So we have numbers 1 to 5, and then you will select your answers from this A to F. Okay, for example, number 1 is letter correct, letter B. Okay, so that is 4 factorial divided by 1 factorial times 3 factorial, applying our formula. Okay, the number 2, we have the answer which is correct, letter A. Number 3, okay, letter E. Next one, number 4. Very good, letter D. And the last one, we have letter F. Okay, I hope you got them all. We have independent activity number 3. So on this independent activity number 3, you are going to determine the situation that involves a combination. Just put a check mark if the situation involves combination and X if not combination. Okay, so let's have this first problem. Opening a combination lock. Before you answer or put a check or an X here, observe that or analyze the problem. In a combination lock, you need to arrange the pin or the numbers, right, before you open a combination lock. Once you did not get the correct arrangement of the numbers in the combination lock, you cannot open it, right? So therefore, that means order is important. And if order is important, that refers to very good. You are referring to permutation. And this cannot be called a combination. So your answer for number 1 is X. Okay? So I hope you got problem number 1. Number 2, placing 10 books in a shelf. If you will just place the 10 books in a shelf, just place it, it is not mentioning here that you are going to arrange. So if you will just place the books in the shelf, that is simply a combination. But when it says here, arrange the 10 books in a shelf, you are referring to permutation. But take note, this is just placing 10 books in a shelf. So therefore, this is an example of very good, not permutation. And this is combination. So it is a check mark. Okay, next one, number 3. Finding the diagonals of a polygon. If you will find the diagonal of a polygon, remember that in a diagonal, there must be 2 points. So therefore, if you will connect the 2 points, for example, point A, point B, or point B, point A, that is considered as one diagonal only. So therefore, order is not important. And that means this is an example of combination. Very good. So it is a check mark. Okay? Let's proceed now to number 4. Putting 6 toppings on a pizza. Okay? If you will put the 6 toppings on a pizza, you are not arranging, right? The order is not important here. Okay? So therefore, this means that it is a check mark or combination. Next one, number 5. Choosing 5 basketball players from a group of 9. Okay, if you will choose, that means you will select. And if you will select, okay, no matter how you select them, or you have selected them, order is not important. Very good. And that means it is a combination. So we have a check mark. I hope you got those 5 problems. Let's proceed now to problems 6 to 10. Okay, so we have this for more practice. Number 6, winning in a contest. If you will win in a contest, what is it? Okay, so it is not a combination. For example, in winning a contest, it could be first, second, third. Okay, so therefore, that means order is important. Okay, and when order is important, then that's it, not combination or permutation. Drawing a set of 6 numbers in a lottery containing numbers 1 to 45. So, for example, you are playing a lotto or something like that. Okay? And then drawing or getting or choosing a set of 6 numbers. There is no arrangement here. As long as you get the 6 numbers in that lotto, okay, you will be a winner. So, therefore, order is not important here. And that means that is an example of combination. Correct. Okay? So let's proceed now to the next one. Number 8, entering the PIN number or the PIN, the personal identification number of your ATM card. So order here must be important. You must not interchange the numbers, right? So therefore, order is important, and that means permutation. So combination or not? It must be not combination. So X. Okay? So how about number 9? Picking a first, second, and third place winners from 10 contestants. So since there is first, second, third, that means order. That means arrangement. So therefore, order is important, and that is permutation. So not combination. Okay? So let's proceed now to the last number, 10, answering 2 essay questions out of 8 essay questions. If you answer questions, just for example, first question, or second question, or question A, question B, or question B, question A. So that means order is not important. Okay? It doesn't matter whichever question you have answered first. So that is only 1 count. And that is referring to combination. I hope you got them all. I hope you have learned something from this video tutorial. See you again on Mike Math TV next time. That's all. Stay safe, everyone. Bye.